A matrix is an ordered rectangular array of numbers or functions. These numbers or functions are called the elements or the entries of the matrix. We denote matrices by capital letters. For example, A, B, and C are three matrices. Notice that elements of matrix A are real numbers. For matrix B, they are complex numbers, while in matrix C, the elements are functions. In a matrix, the horizontal lines of elements are said to constitute the rows of the matrix, and the vertical lines of elements are said to constitute the columns of the matrix. The matrix A has 3 rows and 2 columns. Matrix B has 3 rows and 3 columns, while matrix C has 2 rows and 3 columns. Order of a matrix. As we have seen, matrices are usually denoted by using uppercase letters, while the elements of the matrices are represented using the corresponding lowercase letters, with 2 subscript indices for the position in row and column. The entry that lies in the ith row and jth column of a matrix is typically referred to as the ij order pair, ij, or ordered pair, ijth entry of the matrix. For example, in the given matrix A, the entry in the second row, third column of the matrix A is 7. An asterisk is commonly used to refer to all the rows or columns in a matrix. For example, AI asterisk refers to the ith row of matrix capital A, and A asterisk J refers to the jth column of matrix A. The matrix A having m rows and n columns is denoted as shown. A matrix having m rows and n columns is called a matrix of order m by n or mn. So, referring to the examples shown earlier, we have matrix A as 3 by 2 matrix, matrix B as 3 by 3 matrix, and matrix C as 2 by 3 matrix. Observe that A has 3 into 2, 6 elements, while matrices B and C have 9 and 6 elements respectively. Consider the following information regarding the number of men and women workers in 3 factories, 1, 2, and 3. There are 50 men workers and 29 women workers in Factory 1. In Factory 2, there are 60 men workers and 25 women workers. In Factory 3, there are 40 men workers, 12 women workers. First, represent the information in the form of a 3 by 2 matrix, then find out the entry in the third row and second column. Since the required matrix must be a 3 by 2 matrix will have 3 rows and 2 columns. Let us represent the rows as R1, R2, R3 and columns by C1 and C2. Row 1, row 2 and row 3 are the workers of Factory 1, Factory 2 and Factory 3 respectively. Columns 1 and 2 represent men workers and women workers in the factories respectively. So required matrix A will be as shown here. The entry in the third row and second column represent the number of women workers in Factory 3. That is, the number of women workers in Factory 3 is 12. Example: if a matrix has 10 elements, what are the possible orders it can have? We know that if a matrix is of order m by n, it has m multiplied by n elements. Thus, to find out all possible orders of a matrix with 10 elements, we will find all ordered pairs of natural numbers whose product is 10. Thus, all possible ordered pairs are 1, 10, 10, 1, 5, 2, 2, 5. Hence, all possible orders are 1 by 10, 10 by 1, 5 by 2, and 2 by 5. Example: construct a 3 by 2 matrix whose elements are given by Aij is equal to 1/3 into absolute value of I minus 4j. In general, a 3 by 2 matrix is given as shown. Now, the element Aij is equal to 1/3 of the absolute value of I minus 4j. Here, I can take values 1, 2, 3 and j can take values 1, 2. On substituting values, we get A11 is equal to 1, A12 is equal to 7 over 3, A21 is equal to 2 over 3, A22 is equal to 2. A31 is equal to 1 over 3, and A32 is equal to 5 over 3. Hence, the required matrix A is given as shown.